In this lecture, we'll see how to interface temperature sensor with Arduino. Here, we are considering LM35 temperature sensor. LM35 is a temperature sensor which can measure the temperature in the range of minus 55 degrees Celsius to 150 degrees Celsius. It is a three-terminal device. It contains the three terminals as one is VCC and another one is Vout and the third one is ground. Whereas VCC is connected to plus 5 volts and ground is connected to ground, and this Vout is connected to any one of the analog input pin of our Arduino board. And it provides the analog voltage which is proportional to the temperature. That is, higher the temperature, it provides higher output voltage. The analog output voltage can be converted into the digital form by using internal analog to digital converter of our Arduino board. LM35 output voltage is proportional to centigrade per Celsius temperature. LM35 Celsius per centigrade resolution is 10 millivolts. 10 millivolts represent 1 degree centigrade per Celsius. That is, if LM35 outputs 100 millivolts, it equivalents to the 10 centigrade per Celsius. It can be derived just by dividing the 100 value with this 10 millivolts. So then it is equals to 10 centigrade per Celsius. So finally, you should remember that its resolution is 10 millivolts. So whatever the output we are getting, it must be divided by 10. It can measure the temperature of the surroundings within a circle of between 100 to 500 feet. Now, I'll see that how to convert the LM35 voltage to the temperature formula or equation on concentration on this Arduino board. Already we know that Arduino analog pins can measure the voltage from 0 to 5 volts. And the analog pin resolution is 1023 starting from 0. So that means the plus 5 volt represents with the value of 1023. So if LM35 maximum output voltage is equals to 1500 millivolts. So what is this 1500 millivolts is nothing but it represents the 150 degree centigrade. So already we have seen that the LM35 temperature measures the range from minus 55 degrees Celsius to 150 degree Celsius. So here we are considering the maximum value is 150 degree Celsius. So the same 150 degree centigrade can be considered to determine the maximum output voltage. So finally, the LM35 maximum output voltage is equals to 1500 millivolts. That 1500 millivolts is equals to 1.5 volts. Arduino analog pin can count the 1.5 volts which is equals to 307.5. So how to calculate this? 307.5 is nothing but 1.5 volts by 5 into 1023. So this 5 represents the maximum analog voltage which can be measured by the Arduino, and this 1023 refers to the maximum analog pin resolution. So the plus 5 volts which is represented by 1023 and 1.5 volts which is the maximum voltage can be produced by the LM35 is represented by 307.5. So the new Arduino LM35 resolution is equals to 307.5 by 150 which is equals to 2.048. So here the 2.048 is equals to 1 degree change in centigrade per Celsius temperature. So here, whatever the temperature value you are measuring from the Arduino analog pin, that must be divided by 2.048 to get the temperature in terms of centigrade per Celsius. The same we had written in the program. So before going for the program, we'll see that how to connect this LM35 to the Arduino. So already we know that LM35 contains three terminals, whereas the VCC terminal is connected to the 5 volts and the ground terminal is connected to any one of the ground pin, and this voltage value is connected to any one of the analog pin, and presently we had connected this output voltage of this LM35 to this A1 analog pin. Now we'll see the programming. So as per the previous description, we have connected this LM35 to the A1. So first you should write down that particular variable, or otherwise you can directly use this A1 value. So next we are printing all these temperature values in the serial monitor. So within the setup you should write down the baud rate settings by using the statement such as serial.begin of 9600, whereas the 9600 represents the baud rate. So in the loop we are writing the calculation part. So here, since we are reading the value from this A1, we have to use the instructions such as analog read of A1 or analog read of this LM35 underscore pin. And whatever the value is read by this A1 pin, that can be stored in a variable which is an integer variable, that is temperature ADC value. And already we know that whatever the value we are reading from the analog pin, that must be divided by this 2.048, which is calculated by using this formula to get the voltage in terms of centigrade per Celsius. So now whatever the value you had calculated, that value you are displaying by using this serial.print statements. Right, and after some 1 second delay, again we are reading the value from the A1 pin, and it can be converted by using the formulas. So continuously it will display the values. So in this way we can read our room temperature by using LM35 Arduino and by using this particular calculations. Thanks for listening to class. In the next class, we'll see one more topic related to the Arduino interfacing. Thanks for listening to class.